Okay, so let's start with the new tutorial that is on CloudOps performance. So, what is CloudOps? CloudOps is an operations practice for managing the delivery, optimization, and performance of IT services and workloads running in a cloud environment. Whether an enterprise is operating with a multi cloud, hybrid cloud, or private cloud strategy, or cloud ops is intended to establish procedures and best practices for best cloud based processes in much the same way DevOps does the application development and delivery. Some see CloudOps is a continuation of IT ops, the operations and processes that an IT department administers within an organization. But a more accurate way to define the relationship between the two is that CloudOps uses IT operations and DevOps principles applied to the cloud-based architecture to improve the accelerate the business processes. CloudOps, however, is more than just an IT ops because cloud-based applications and data management additionally require new technology, new tools, and new skills. The primary objective of CloudOps is to eliminate downtime for cloud computing and therefore make continuous operations in a reality. Cloud operations are proactive, not reactive. Problems are solved before they occur. Is a storage instance having performance issues? CloudOps helps identify the problem so that you can move data from one system to another before the first malfunctions. In an attack spotted, CloudOps makes sure the alert goes out and can even execute the actions required to block the IP address. Through cloud operations, these activities and remediations can be automated so that the end user experiences zero hiccups with cloud applications and data. Before we go further, let's try to understand the difference between CloudOps and DevOps. CloudOps is an extension of DevOps, complementing the latter by using cloud computing tools instead of on-site network server and taking the cloud's operations that DevOps enables into cloud. DevOps is a methodology that helps IT operations and development teams collaborate more effectively, which includes practices and procedures that help organizations shorten their development cycles, reduce time to market, and continuously improve software delivery and quality. These processes ultimately add up to create higher levels of uptime, improved quality of service, and positive customer experiences, all critical for a successful digital transformation strategy. CloudOps functions and objectives. The functions of the CloudOps team within an organization require a wide range of skills sets across an organization, including IT operations and other IT teams, DevOps teams, business application operation teams, and cloud service providers. The overreaching objectives of CloudOps are to keep cloud services and cloud infrastructure up and running, optimize performance and capacity, ensuring that the cloud budget isn't expended on wasted space or idle resources, and keeping tabs on operational costs. Meet service level agreements, manage compliance as well as configuration. Make sure here are proper recovery and mitigation measures in place. Managing a cloud environment. Some organizations have realized that traditional IT service delivery models do not work for cloud operations and are now doing cloud ops with new cloud perform management tools that support deployment, provisioning, operations, and optimization. However, while almost all organizations are juggling diverse cloud configurations from multi cloud to hybrid clouds, most don't realize until nearly halfway through their cloud migration that they can't manage cloud operations with traditional IT operations or IT ops. In short, some organizations have not yet discovered the importance of cloud of CloudOps, whereas others have developed specific CloudOps strategies and tool sets to handle the growing complexity of their systems. While continuous operations aren't specific to cloud technology, in a cloud environment, it takes the right CloudOps procedures and best practices to prevent unplanned or downtime and outages. With auto and self provisioning, organizations can set up dual redundant systems that allow operations to remain up and running in the case of system and software updates as well as system failures. In addition to redundant systems, cloud allows for abstraction and management software that helps systems work around failures and updates. These include cloud management platform, that is CMP, tools that can automate continuous operations as well as operations when system failures arise. CMP tools enable self-healing when failures in storage, network devices, and other system occurs before end users experience the issue. Metrics and monitoring systems tools on public and private clouds with proactively identifying issues rather than data on the state of the system. Then kickstart automated procedures to resolve problems in advance. So we need to be clear that to reach zero downtime and achieve continuous operations in the cloud isn't just happen with one fix or all tool or solution. Some questions and steps organizations interested in CloudOps need to consider are determining that what applications and data sets they plan to host in the cloud and what will be required to migrate them to a cloud platform. Creating and updating a deployment plan to prevent applications and system updates from instantly halting operations and to dramatically reduce or completely eliminate unplanned outages. Using the auto and self provisioning mechanism of your cloud perform platforms to build redundant services. Selecting CloudOps tools including CMP and monitoring tools. Best practices for managing CloudOps. Managing a CloudOps environment requires an entire organization to embrace a paradigm shift. It demands a separate team indicated to IT operation or dedicated to IT operations in the cloud, incorporating expert on security, IT, cloud services, compliance, and more. Increasingly, businesses have acknowledged this need or dedicated CloudOps or operations team. According to recent Flexra State of the Cloud report, 66% of the enterprises already have a cloud COE, Center of Excellence, and an additional 21% are planning one. Weighing the risks and benefits of CloudOps. Cloud-based platforms have a unique advantage over ones that require an on-premises network operations center. They are far from more scalable, more infrastructure agnostic, more latency deterrent or tolerant, and more automated. In particular, the intersection of cloud computing and DevOps yields immense benefits. Using cloud services means organizations have more flexibility and scalability, and cloud ops help services be more secure and reliable. Some of the advantages include cost effectiveness. Cloud computing lets organizations save on not only hardware costs but also on expenses from utilities, facilities, and other components required for the upkeep of physical infrastructure. Scalability and flexibility. An organization can easily adjust cloud capacity to accommodate its needs. Teams no longer have to worry about finding extra space or configuring new hardware each time cloud capacity expands. Automation, that is cloud, comes with several perks: provisioning infrastructure, creating builds, running quality tests, creating reports, and more functionalities that automate processes and ultimately reduce time to market. Disaster recovery, fires, hurricanes, tornadoes, your cloud infrastructure is resilient against many types of disasters. Unlike physical infrastructure, cloud-based systems let you store data in multiple locations. Continuous operation, update and deploy software without skipping a beat or causing service disruptions. These benefits are typical of cloud migrations in general, but just because you have cloud infrastructure in your environmental environment doesn't mean you will realize all the advantages. CloudOps optimizes your organization with the right price practices and procedures so you can really get the most out of your cloud infrastructure. CloudOps challenges include the possibility of budget overages as well as governance issues. Budget issues. Organizations waste on estimated 30% minimum of their cloud budget as a result of inefficiencies and idle resources. Cloud computing may be scalable, but that scaling often comes at a cost and should keep in step with the organization's associated cloud budget. Want to learn more? Check out our post covering recent IT spending and budget trends. Governance. Another potential adverse effects of quickly scaling is lack of governance. Rapid deployment may make it more difficult to have proper oversight of all workloads in the cloud and manage budget, governance, and compliances. Cloud Ops culture, like DevOps, Cloud Ops success tests rests heavily on developing a culture geared toward making the most of the framework and tools. And as more organizations move more work and processes to the cloud, they need to focus on building cloud ops expertise. Most clients live in a state of reaction when dealing with the cloud and cannot respond to events, changes, or requests for new services. Totti Wittis Thompson says CloudOps establishes the structure for deployments enabled via automation, allows for monitoring, reviewing, and optimizing existing resources, and examines corporate policies for an alignment of the cloud. Stratos Sonis, an expert in cloud ops, agrees that organizations need a broader understanding of the appropriate alignment of proper organization structure, expertise, and collaboration. Cloud ops to really work. Cloud ops isn't a single team or department. The IT, security, architecture, and application teams need to collaborate and be aligned on common cloud ops practices. The CTO says cloud ops doesn't work well if these teams are working in silos. The technology team responsible for implementation need to understand cloud-based architecture, networking security, and automation. It is said without foundational skills, the team could risk implementing solutions where cloud services already exist. Thank you.